Hello, everyone, and welcome to Handmade Hero Show, where we code a complete game live on stream. We are really going to just be continuing the work that we did last weekend. We implemented the beginning of Octahedral light maps for our game. I guess I don't know that we want to call them Octahedral light maps. We maybe should call them Octahedral light probe maps or light probe storage. And we need to sort of push forward on that. There's two things that we want to do today if we can. One is to sort of debug the code a little bit because we just kind of threw it in there. There's probably typos, there's probably mistakes. And the other thing we want to do is we have to tighten up the actual meaning of the map and how it's used. So right now what we did is we just threw in a packing of the maps that I think is 10 by 10 right now. And that is an 8x8 map plus a 1 pixel border around the map. Obviously, there's a 1 pixel border on each side, which ends up being +2. So that's why it's not 9x9. It's 10x10 because there's a 1 pixel border all the way around. But at the immediate moment, we're not actually doing that. We're just using the full 10x10. And so we also need to kind of tighten up that idea and move to actually properly aligning all of our ways that we work with the texture to sample into it properly. So right now it's not really correct the way that we're doing that, so we want to kind of tighten that up today, so accounting for the 1 pixel offset and all that. And we also need to copy, right? We need to place the proper values into those border pixels, so that's another thing we have to do. Once we do all of that work, we're going to have to then, and this will probably start tomorrow because we'll probably need all of today to just make that stuff work. Once we do that, we also need to do one other thing, and that is we need to start streamlining the process of working with these maps and probably moving to some kind of scheme where we just only have one of them in memory and update it directly and that sort of stuff, because there's a lot of business going on right now. And we're not going to be able to afford that. Like, these octahedral maps are actually pretty big. They store the light mapping for the probes at a pretty high resolution compared to something like the low-res voxel version we were using before. And so in order to sort of move towards an actual finished version, which is what we're trying to do here, I think we probably want to change to a system where we're directly operating on a single octahedral atlas. And every time we take a raycast, we just blend that in directly. I don't actually think that'd be that hard to do, and so I think that's probably what we want. All right. So I'm going to go ahead and get started. If I go ahead and switch to Handmade Hero here, what you can actually see is that if we run the game, and mind you, we're not actually doing any lighting right now. So if I go ahead and switch over here to Remedy and load up the renderer here, we're not actually doing any use of the lighting, so you can kind of see that the game itself is unlit at the moment, and that is intentional. But we are actually writing into the light map itself, the storage for these probes, it actually does exist. So we have those probes stored, and at each location in the voxel, we are saving out one of those octahedral maps. So what we want to do here, I think, is start to view that. We viewed it inside the actual, the capture, like we looked at RenderDoc, and we saw that. But we'd like to be able to see that light map more specifically, and right now we can't. So what we might want to do, and I guess nowadays, I suppose since we did the work of doing hot reloading, I could probably just leave, of the actual renderer core, we can probably leave this up and just work with it here. If I go to the renderer, the OpenGL side of things, when we're actually in the middle of the render loop here, and we do bind these images and send down the updated voxel information, we should be able to just draw what they look like directly on the screen. You know, having some, we know like what their dimensions are, right? So we should be able to go ahead and actually just like draw the two light map textures so that we can see what they look like. And if you go and look at what we've got here as far as that's concerned, you can see that we've got, you know, a thing at the end where we resolve our depth peels. So at some point, right, we finish up in the use program begin, use program end. We finish up by doing a bind frame buffer and doing a final blit to the screen. And that final stretch is the thing that does that, right? You can see we have the color handle here and we do all this nonsense, right? And I think, if I'm not mistaken, we should probably be able to, when we do that final stretch, we should be able to put some debug code in here that just goes ahead and outputs our octahedral light map out to the screen in some kind of way that we can visualize. And so if we take a look at the final stretch call, so if I look at this final stretch, what you can see here is there's just a thing which says, look, here's where we're going to put it, and here's the texture lookup that we're going to have. And so I think, if I'm not mistaken, I should be able to literally just do some extra passes here, right? So when we do the use program begin, use program end through this line of code here, I feel like the GL draw arrays call that we're issuing here after the bind texture, I feel like we should be able to just do that more than once, right? So, you know, we've bound an array. This draw triangle strip here, it's going to draw one quad, right? And the quad it's going to draw is whichever one we've lined up as being the active quad. So I think, and let me just double check this is true, I think it's whatever sort of texture array we've armed. And I don't know, so let me see. I don't see us explicitly putting that in here. So I'm assuming, and this is kind of taxing my memory a little bit, but I'm assuming that, you know, in the use program begin, use program end sort of things, we're probably setting up that program information. So, like, if we go look at where that is on here, let me see, we got resolve, fake seed lighting. We don't have one for that one, right? And so when we do the use program begin for the final stretch program, which it looks like, yeah, just looking at it, so it's going to be like one of these common calls here. And if you look, you can see that if there's a, you know, we enable these vertex attribute arrays, right? And we don't actually set anything other than the offsets. So we're not actually specifying an actual array anywhere. We're just sort of turning them on in here. And so whichever one whichever one was last in there is the one that we're going to use. How come I can't? Oh, because I'm already in there. So my question is just like, when did we set up that for that whatever buffer has the for the triangle strip, whichever one has the 4 pieces in it? At some point, we had to actually enable that one, and I'm just not sure when we actually did. So you can see here we set up the frame buffer and all that stuff. Oh, here it is. Here it is. So this GL bind buffer screen fill vertex buffer, that right there. So if we take a look at that screen fill vertex buffer, let me go ahead and pull that out. So if we take a look at the screen fill vertex buffer, like right here, you can see that we've got one that just fills the whole screen with whatever the map is. And we sort of want basically like a debug version of that so that we can draw whatever we're looking at, you know. So we want to draw our octahedral light information into a map using some pre-coded coordinates here. And we know the resolution of our octahedral map because we sort of packed it in a particular way. So we know that it's sort of long and it's sort of wide and not as tall as it is wide. It would normally be because everything in it is a symmetric dimension, right? It's all 10 by 10s, and it's, you know, the light, so I think it's 32 by 32 by 32s worth of 10 by 10s. So it's a cube, but we had to like unwrap the cube. So we unwrapped the cube in the width direction. So we effectively have, instead of 132 wide, we have 32 times 32 wide, and then just 32 tall of these 10 by 10s. And so we kind of need to make a version of these vertices that we can use that will just have around for the purpose of doing one of these light map debugs. And so in here, I'm just going to say like light map debug buffer or something like this, so that we can generate something that will fill this properly and look at it. And if you look at what's happening here, you can see this fills the whole screen by starting off at the X. So this is the left edge of the screen. And 1.0 would be the top, I guess. So I don't really know why we chose this winding, but we did. And then we go from, oh, you know why? Because it's a tri-strip. So we had to do tri-strip order. So we started off in the upper left corner. We went down to the lower left corner. We go over to the lower right corner, and we go up to the top. And so we still basically, want to do essentially the same thing probably, but we're looking at something that if you look at it, if we look at its aspect ratio, oops, I promised I wouldn't use calc anymore, speed crunch. We're looking at something that's 32 by 32 across, but only 32 high, right? So its aspect ratio is 32 to 1. So we want to actually have a height that's going to be proportional. If the width of this thing was 2, right, or 1, I don't know whether we want it to stretch all the way across or only half the screen. Maybe we only want it to stretch across half the screen. So if it was -1 to 0, let's say, then we would only want it to be 0.03125 high, right? And we probably want like 2 of these so that we can do the depth map, and because we have a depth map and a color map. So if we did it that way, we would have 2 of these, 1 for each, right? And so if we just go ahead and think about how we're going to make these work, we can just say, all right, let's suppose that we're just going to go and do -1 to 0. So we're going from the left edge of the screen to the middle. And then instead of going to 1.0, let's just go to, well, I mean, there's no point me typing this in. We'll just create the actual value, which is like the height value here. Or maybe we'll say the top P or something. And so I want to start at -1.0, and then I want to go up exactly that 1 over 32. So that gets me, up to the top of the, where it should be if the aspect ratio were correct for this thing. So then here I'm just going to call this my top P, or top Y might be a better way to say it, right? And that would allow me to draw things that wouldn't occupy the whole screen so that I can just slap some debug stuff up there. And I think that's all I really need to do. I want to have 2 of these, I suppose. I could just do this, right? Which is to say that I'll put another one in here that goes from 0 to 1, and they can just both sit there, and I'll just use different parts of the vertex array. Should be fine, right? And once I specify this, I think I'm good to go. So I don't know when this gets sent down. It's OpenGL and init, so it should only have to happen the first time, which I think is good. I guess that does, do we actually call OpenGL and init again? I don't think we do, so I take it back because this is initialization time. We don't rebind these buffers. Maybe we should, because then they would work during a reload. But so anyway, I'm going to go ahead and recompile it this way. I'm going to need some place to remember that light map buffer. So you can kind of see in here we have the screen fill buffer is a gluent we remember. So we're going to want to remember the light map debug buffer as well. Oop, that has an extra capital U there. And I think that's all we should really need. And then we can do, at the end, we can use that buffer to blit the 2 textures onto the screen and see what they look like. So now inside the OpenGL code here, we just go down where we were using the program here. We can do it inside here because we're using the same program, so we don't need to redo that. So we can just do effectively like something like this, right? we should be able to say, all right, let's just rebind the vertex array that we're using. So in here where we did the bind buffer, we'll switch to our lightmap debug buffer. And then in here where we do our bind texture stuff, we can say, all right, we're not going to use this anymore. We're going to use our lightmap values, our lightmap textures. And so we know that those are, or should be, yeah, right here. So we've got the atlas handle for the colors and the atlas handle for the depth, like so. And we're going to need here a way of picking out different ones. So I believe this is the initial element index. I'm going to double check. I assume it is. So I'm assuming all we need to do is that, but you know, I don't remember the specifics of the draw arrays call at the moment. So I'm going to go ahead and look it up on docs.gl to make sure that I'm not totally wrong about that. Because there's other things it could be. It could be an offset, a byte offset or whatever, right? So it's a gluent for the first, and it says starting index, right? So assuming that we're doing a draw arrays call and not drawing an indexed arrays call, then it should just be the fourth one of the vertices, and that should draw both of them, I think. So let's take a look and see if that does anything for us, and we'll go from there. All right. So we are actually seeing some of the information on here, but you'll notice that it's not doing what I had wanted it to do, right? It's clearly drawing on the full screen, and I wanted it to draw on I only wanted it to draw a part of the screen. So looking at what's happening there, you can see doing an array buffer bind here of the lightmap debug buffer, and then me trying to do my two draws. And I'm not actually sure why that would have happened. Like, I feel like that should have worked okay, but I'm not sure why. So let's go ahead. I probably just passed the wrong thing or something. So let me go ahead and look at the call that actually initialized those. So if I go to lightmap debug buffer and look here at what happened, let me just see what the problem is. So we gen the buffer, we bind the buffer, we send down these vertices, and these are the UV coordinates, so they shouldn't have to change. These are the positional coordinates, and I'm not really sure. Like, I don't actually see why that would immediately be a problem. It looks sort of like it's not actually using the bind buffer here. So I'm wondering if for some reason I'm not binding it. Oh, so here's a question. It may be that you can't swap a bind buffer without recalling the vertex attribution calls. I'm not sure about that. We could test it pretty easily, so I suppose I just should, but then we'll have to look at why. So I'm just going to see if this is true. If I use program end here, change the bind buffer, and then restart the program, I'm wondering whether or not that changes anything. Yeah, so that does, right? And you can see those textures are down in the correct place now. So that's a little weird, and I guess I don't know why, so I kind of want to take a look and see, is that actually what the expected behavior would be? And maybe it is, and that's fine, but I'm just a little bit weirded out by that. So does that imply that basically these calls are going to bind that buffer, whatever buffer was active at the time, and it doesn't matter if you try to switch the buffer out, it won't actually take a new one? That appears to be the case, which is a little bit weird because these calls don't actually need that, right? These are just specifying a vertex format. But, you know, I don't know. It looks like maybe that's exactly the case. It doesn't matter. I'm fine with it that way. But anyway, now we can sort of see when we run the game, we can see that we've got both of those textures down there. And, you know, if I had to argue, I'd say that does look about 32 times longer than it is wide. Now, we have a problem, which I can see here. It's too much data, right? That it's so tiny that it's impossible to actually see what's going on in that texture. So I guess I'm not sure that this will actually help. We may need to look at like a subset of it, right? Like we may need to just focus on a part that's significantly smaller so that we can see anything. I'm not sure what the best way to do that would be. But anyway, we now have that part working. So if I actually go and change what that, what that amounts to, so that we maybe make it a little bit higher and change the UV coordinates, I don't know. That seems like the only thing we could really do here to help. So if we wanted to do that, what we could do is draw like a fairly significantly, a much smaller subset of this thing. So what I could say is like, all right, there's a UV dimension, and we're gonna like shrink down how much of this texture we're drawing, right? So I'm gonna go ahead and say, maybe this will be something that specifies both of these. And then on here, I'll just say like, look, UV, well, these are the 0, I guess is an offset. So maybe we'll say something like this, UV min, UV max, so that I don't have to specify each of these individual coordinates. So I'm going to just say, all right, this is UV min x in both of these, and then this is UV max x. And then this is UV min y in both of these. Oops, sorry. UV min x in both of these, and UV max x in both of these. And then in these, we'll just have UV min y. Actually, that's max, sorry. UV min y, UV max y, UV min y. And each of these is just going to be adjustable now. Oops. And that way I can say, look, we're going to pick out a smaller subset of this thing. And I think I want to focus mostly on the, center of the thing, because we're going to be trying to center the voxel around us. So I want to try and pick a location in the map that has something to do with the center. Now, we know we unwrapped it XY wise, so I guess it's pretty hard for us to really pick out the center in any meaningful way, but we can at least do up and down. We can pick out the center. So we can pick out the center Z at the very least. So maybe we say, look, the Z center would put us somewhere like, let's suppose we went like that. So we had like, or maybe even something like that. So we're just talking about a very narrow part of the map. And then if we wanted to here, like, let's suppose that we were doing sort of a square. So if we were doing a square part of the map, well, we know that, again, this map is going to be 32, right? The UV coordinates are normalized from 0 to 1. But the map itself is not uniform, like it's not square, right? So if we wanted to have a part of the thing that would correspond to this, it would have to be 32 times the span here in order to get a square part of it out. And so if I take a look, I guess that means I want to know, where's SpeedCrunch? So if we said, look, we have, looking at this, it's 0.1. So 0.1 times 32 is too much. So I guess we want this to be even smaller, right? So maybe we say something like, look, it's something like this. So now it's just 0.02, maybe even that. So now it's just like 0.01, right? So, oops. So it means that we only need to cover 0.32 in the x direction to capture that much y, right? I'm making this up as I go along, right? But basically that means like it's 0.16 radius. So if we were 0.05 minus 0.16, right, and 0.05 plus 0.6, the problem is that straddles the boundary, so I think we probably actually want to be more like that. I mean, I don't even know where we want to be in the map x-wise, but, you know, off we go. So we can do something like that, and then all we would do here is just say, look, at that point, the top y is going to be 0. So we're going to actually draw a square now, and off we go. So I think that's all we really need to do to see a more representative part of the map. Unfortunately, you know, like I'm not sure, again, because it's a lot of data there, I'm not sure how to display it at the moment in any particularly useful way. You can see now we're looking at a more, perhaps, zoomed in region of it. It looks a little weird. I'm not sure why we're seeing the kind of stipple we're getting there. It may be because the format of the texture, like I don't know why we're seeing exactly what we're seeing there. So we're gonna have to look at that a little bit more closely. It looks stretched as well in a way that doesn't make a lot of sense to me. So I think these are not quite correct at the moment. We are now drawing a square though, right? Because top y is 0. I mean, well, let me put it this way. If you look at this thing, it should be roughly square. Of course, it's not really. I guess that's because this is not quite a square. This is 16 by 9. So these will be 16 by 9 as well. So let me make those squarer, for lack of a better term. Because again, these are also coordinates that are, the coordinates in this case are also going to be interpreted normalized over the screen, which we know is 16 by 9. So we would want them to have a 16 by 9 aspect ratio for these coordinates as well, so that when adjusted, they'd work out. So what I probably want to do here is say, all right, where are we going to in x? So we've got like a max x here. And this with, when we do this max x, or maybe I could even say this is xdim, right? So I'll just write these in terms of some starting location and then like an addition. So, well, actually, probably more like that. And so now if we did xdim equals 1, we'd get back the same thing, but if we do xdim equals something that's aspect ratio appropriate, we'd shrink these down to a square so that we're at least looking at the right aspect ratio for a square slice of the texture. And so in that, to that end, right, and maybe I want this to be even a little bit fancier, so maybe I want this to be like 1.0 minus xdim, so that like the middle of the screen is a gap, you know what I'm saying? Oops. And so then if I said, all right, let's make xdim, like I said, 1. If I did that correctly, there we go. I should get the same thing. And then if I change it so that I'm actually looking at an xdim of a value that's properly adjusted for 16 by 9, then what I should be able to do is get those to both be squares that are bound to the edge of the screen. So there's a square on the left side and a square on the right side that are at the edges of the screen, but don't extend all the way to the middle. And in order to do that, like, again, I know that this is going to be proportional to 16 by 9, right? Because that's the resolution that we're rendering at. So I know that if I assume that we're doing 0 to 1 on y, I want to do something that's 16 times but divided by 9 that in x, and I don't actually want it to, not sure how to say this properly. So we know that on the screen we're drawing 1 in y, but that 1 in y is proportional to the 9, and we have something that is going to be interpreted proportional to 16. Right? So this is going to want to be inverted. I need to draw this out because I'm explaining this very poorly. Let me grab the... You know, I'll be honest, I don't know where the pen went. There it is. All right, here we go. All right, so if we have our screen and it looks like this, then what we're doing is we're specifying coordinates that are interpreted on a screen that we know is 16 by 9, right? And right now what we're doing is if we specify 1 here and here, which is what we're doing, a length of 1, right? Then what we're going to do is this length is going to be effectively 1 times 9, right? And this length is going to be 1 times 16. But we want them to be equal, right? So in other words, we want to take and say, look, we know we're doing 1 times 9. And so we want to say, what would the value be for our width, where width times 16 is going to be equal to 1 times 9, right? So if width times 16, I'll just write this in math now. So if 16w equals 9, then I want w to equal 9 by 16, right? Does that make sense? And so if we look back at what we're doing here, that's why, like, I was going to say, like, we invert this, and I was trying to explain why, and that's why. Because what we're actually doing, although it seems like the x should be 16 by 9 because x is the 16 side and y is the 9 side, what's happening is they're getting multiplied by those values when they actually go to get rendered. So we're trying to, like, undo the multiplication, right? We're trying to reverse the 16 by 9 multiplication that's happening during rendering as it blows it out to a screen of that size. So in theory, if I invert that fraction, I should now get something that does the correct, like, fractional difference between those two. And there we go. So now we're drawing actual squares. And now we just have to figure out why we're obviously not putting very good, we're not properly selecting those UV coordinates at all at the moment. And we got to go see why. I may have made the same mistake when we did the textures. Like, I should have had a wider version in Y, right? Like, I think what I did is when we, yeah, so like here, this is the wrong way around, right? I needed to make it so that this was taking a, like, larger section, and I think I probably did it the opposite way that I should have, right? It needs to take a smaller section because the texture is bigger. I think that's, again, not explaining it very well, but we're trying to grab a piece of a texture that's very wide but very short. And when we go to grab it, what I did was I said, like, oh, we're going to grab a 0.01 size slice in Y out of the texture, or in V, depending on how, Y or V, depending on how you want to think about it. And so I need to do one that's 32 times larger in the X direction because the texture is 32 times larger. But it's the opposite's true, right? Because the texture is 32 times larger, that means that whatever UV coordinates we pick, we're going to be getting 16 times more, 32 times more of that thing than we would have gotten with the same slice in Y. So we actually want it to be 1/32 of the amount we pick here. So actually, I could definitely have done this the other way around and said, oh, all right, so if we take a 0.1 there, it's not going to be times 32 to get the other one. It's going to be divided by 32 to get the other one. And that's the value we're actually going to use there, right? So that's actually what I should have done, and that was just me kind of having a brain fart. I often have that problem. Like, it's just, you're thinking about the ratio one way, but the ratio actually goes the other way because it's being multiplied by that thing. So you're, like, undoing the multiplication. And if you do the multiplication the same way, then you're actually, like, doubling the problem or squaring the problem, depending on how you look at it. So I think that's now the correct way to look at it. And we might have to try and find a way to grab enough of the image now to make it make sense. Obviously, that's a pretty small section of it, so maybe we'll try to make that a little bit wider. Let's write this proportional. So let's just say, like, VSpan, and let's say that we want a VSpan of, like, well, we'll start with the whole thing. we'll say 0.5, and then we'll narrow it down as we need to go. So we'll say 0.5, which means that this is minus the vspan, this is plus the vspan, and that would take the whole thing. And then we can just do uspan, and the uspan, like so, can just be proportional to the vspan in exactly the way that I said. So it can just be the vspan divided by 32, and that should give us a proper square subsection of it, assuming I don't accidentally capitalize the letter. And once we have that, we should be good to go. Right? So let's go ahead and run it. There we go. So now we can actually see part of our light map here. And I'd like to try and get a part of it that we actually visually see. You know, I can see there that we're getting it. What I might do, because there's no reason not to, is if we go back and you take a look at what's happening here, where we do the gen buffer bind buffer here, if I were to just move this out, so, you know, let's suppose that I just took this thing and I said, okay, you know, here's the part that gens the buffers. And in fact, you know what? Let me just do it this way. So if I just said, all right, here's the part that gens the buffer. So here's one gen buffer call. Here's another gen buffer call. These two I can just run anytime I want. So if I was to move these into the part where we do our change settings call, if I did these here, then I believe I would just be able to, like, you know, if I do this, I believe at that point I would just be able to hot code reload this part because it would run anytime we reloaded the code, right? So I'm pretty sure that if I start off now with a fresh compile, having moved that into the part where we do it every time we change the settings, if I run it now and then I go here and start mucking with those values, I think they should update, right, in real time. So if I wanted to change the vspan to like zoom in on this, let's say I doubled the vspan, I think after that compile's done, it should just like change in when we run it, and you can see that it did, right? So there it is. So that will allow me to kind of focus in on a value that a part of the texture that I want to see. And so since we have the UV min max part of this happening, right? What I'd like to do is change this to a vector equation so I can basically say like UV center here or something. And then the UV min max can just be like UV center minus UV span. And I'll just make those two values be part of a vector, right? So if we look at what that would do, I just say UV span that's the dimension there, the U-span and the V-span bound into a vector. And then the center at the moment is 0.25, 0.5. So if I delete this out and I just make this UV center plus UV span and minus UV span like so, now we can just set the center to look at whatever part we actually want, right? And if I was super motivated, I could even make that just be like a debug value or something that we move around, but we've never really gotten the debug system into a particularly good place, so it's more annoying than it should be. But let's just try this. So let's suppose I look at a part slightly to the left. Does that move this into focus a little bit more for us so that that's in the center? And you can see now it sort of is, right? And as I move, through this thing, you can see how those octahedral lighting results are kind of being modified as I move around. See what I'm saying? And I want to zoom in probably just a little bit more and center it just a little bit more. So, you can see it's kind of like needs to be moved over to the right a little bit more. And it needs to be moved like up a little bit as well. So, probably want to do something like that, I guess. I don't know. Or am I going the wrong way on Y there? Or on V, I should say. Yeah, I think I am. So let's say that's 3.5, and instead of a 0.45, we'll say like 5.5 or something like that. And still, so probably want to say that. I'm not sure exactly what that center value for X should be there. There we go. That's pretty darn close. So you're looking at that part, you can kind of see how it goes, right, as I'm hopping through it. And I might want to zoom in a little more on that. So if we took the V-span and doubled that to zoom in on just the center part of it, I think that would probably be good, right? So now we can really look at that octahedral light map, and, you know, looking at it, I guess what I would say is it's kind of hard for me to really tell. It's not obviously wrong, but I'm a little nervous that the unwrapping is still not quite correct, right? Like, I'm not sure about that. It's nice that we can see it, certainly. But I'm just not necessarily sure that we've got that unwrapping right. And part of the reason for that is you can just see that there's sort of some weird, I mean, you know, it's possible that those are in the right place, but that doesn't feel quite congruous to me. It seems like it's always kind of out on the corners, maybe a little bit more than it should be. I don't work with octahedral maps. It's the first time I've ever looked at them. So it could just be my unfamiliarity with them, that this is what they should look like generally. But I don't think so. I think there's probably still some unwrapping bugs in there. All right. But either way, that's good. Like, I'm pleased with that because, you know, we're in a pretty good shape here as far as like being able to see at least something that's going on. I will say it's not completely wrong. Like, it definitely looks like okay, but it's just I'm not 100% convinced of the accuracy there. And there's a couple of things that we can do sort of to fix that. And here's what I would propose. So I think what I want to do before I correct any of the errors that we have yet, like not using the border and so on, I want to go test that octahedral mapping carefully. And so what I'd like to do is I'd like to go and write into the octahedral map using the octahedral unwrapping of the map in such a way that I put each octant of the octahedron on a separate color. So I can then look at the octahedral map and actually see whether my sphere octants are going into the locations that I think they should be going into. And more importantly, whether they're at the place in the map that I think they should be based on those quadrants. I think that's something we probably want to do. Now, in order to do that, I want to be able to turn off the blending on these maps. So when we go look at that code there, right, you can see we've got sort of this stuff where we're like, hey, here's, you know, whether this thing is linear or clamped to edge or whatever else. And if you look at this, what I would like to do here is do the same trick I just did, because I want to be able to switch these between blended and linear anytime I want to. So I don't want to have to restart the game to turn off blending on my light map. So if we change to settings and we go in and do basically exact same thing, so exactly like this here, where we set those textures, you can see here, for example, we're setting some min filter, mag filter stuff for, like, you know, mip maps and whatever. I want to do exactly that same thing for this stuff. Excuse me. So I want to go ahead and bind the light color atlas, and then I want to set its parameters here, right? And I want to go ahead and so that this is really only doing just, it's not setting the parameters, it's doing just the actual creation of the texture that we don't want to change. And then I'm going to do the same thing with the depth handle. And that way we can play with these as much as we want. We can change what they do and how they do them. So that if I want to change one of these, I can easily do it. And what I'll say is maybe we'll have a blend mode here. So we'll say like, okay, there's like a atlas or light blending equals. And I can just do, maybe I should say light sampling. And that way I can just change that one variable, and then all of my sampling will change anytime I want it to. So if I go ahead and run that, what should happen now is anytime that code, anytime we recompile that code, we should change the blending. So right now you can see it's very smeary. It's doing linear sampling. So what I want to do now is see if I can make it so that if I switch to nearest, this will turn into a pixelated display. And it did. So that's better for debugging. I'd rather see the pixelated version so I know like what kind of resolution there is in there, and I'm not trying to figure out what is a pixel and what is just a blend between two pixels. So that allows me to see specifically what we're storing, and that's what I want. Now, by the way, I should mention this entire time, the reason this one over here is completely red is because we're not using the depth channel at all, right? We have a depth texture for our light mapping, and we're just not doing anything with it. That's intentional, and we're going to leave it that way until we actually get the rest of this working. So I want to go debug this part now and see what I can see about that. So if we go to where I'm actually writing into that, in the lighting test, I'm just dumping down some values based on preconceived notion of where a light would be. And you can see in here, right, so if we take a look at where we're writing into it, here's the light voxel information where we put that stuff. So for each one of these, what I'd like to do is say, all right, when we do a write in here, we're going to do a unit vector from Octahedral here. And what I want to know is for each one of these, and I can't really test the reverse yet because I'm not really doing the reverse version, but for this, when we say unit vector from Octahedral, what I want to do is let's turn off the part where we actually do any lighting. So let's just turn that right on off. And what I want to do instead is place some code in here that will set the light color to a known value. So for example, if I was to set this to, let's say blue, right? Then I should now see all blue on the left side of my image, right? So there it is. And obviously we're not setting the depth to anything at the moment, so it's just going to come out black over there, and that's fine too. So now what I could do is say, all right, let's take a look at when we get back the unit vector from Octahedral here, let's see what it's telling us these sample directions are. And so if I was to create like a pretty simple sort of little like decoder here, and I said, take the sample direction and take a look at the absolute value of the x, right? And if the absolute value of the x direction is greater than the absolute value of the y direction, and the z direction, right? So it's the maximum one. It's the maximum value of the values that we have. Is that parenthesized properly? No. There we go. If it's the maximum value that we have, we'll set it to one thing, right? If it's not, we'll check the other way around, and then we'll check the final way, right? So this is basically saying like, we'll just look at which one is highest. And so if the x is highest, then what we'll do is we'll set the x equal to, we'll set the red, right, channel, the green channel, or the blue channel based on which one's highest. And now what we haven't done is differentiated between the positive and negative quadrants, which we would like to do. But for right now, we're not going to do that. We're just going to look. And what we see if we look here is, I don't know, I'm not sure I could really call that correct, but at the same time, it's not obviously wrong either, right? Like, it's a little bit hard to tell. So I'm going to go ahead and finish that part and see. I'm going to differentiate between the positive and negative halves of these. So I'm going to say, look, if sample dirt x is less than 0, right? Then I'm going to do dark blue. Otherwise, I'm going to do... Oh, actually, you know what? Well, no. Right, so now dark will be positive and... I'm sorry, dark will be negative and light will be positive of each of the values. There's the green version. Sorry, blue version here. And off we go. So if the absolute value of the x coordinate is greater than both the absolute values of the y and z, then we will color it red and we'll use a dark red for negative and a bright red for positive. If the y is greater than the x and the z, then we will do the same thing with green. And if the z is greater than the x and the y, then we'll do the other one, right? And I could have just done an else here, I suppose, because we know that basically, like, I mean, maybe this is the smarter thing to do. Right. So we'll just get a blue in the case where, neither of the other two were true. At that point, we should be able to see if this thing looks like an octahedron or what, right? And so looking at it here, that's not correct. This doesn't quite look like an octahedral map to me. And so I think we've got a bug somewhere. Now, it doesn't necessarily mean that we have a bug here. For all I know, this thing's writing into the thing wrong. You know what I mean? Like, this could be wrong, right? I'm going to look at the octahedral mapping first and see. But I guess one way to test this as well would be if now that we know that we're not seeing quite an octahedron, what I could do is just say, look, well, let's see if we're actually writing into this thing in the pattern we think. So if I set the light coordinate here, what I could do is say, look, we know we've got a tx and a ty, and we know they're based on these values, so let's just see what happens if I do tx divided by whatever this thing is, right? And in fact, you know what? I don't even need to do that because we've already got it. It's the oxy here that we're feeding in. So let's just draw the oxy. And we'll draw the oxy as sort of an red getting increasingly bright from left to right, and green getting increasingly bright from up to down. And so if we look at that, what we can sort of see here is like, at least nominally, it sort of looks correct. Now, there's some issues here, so I'm not really willing to say that this is correct. Because if you look at what we're getting, if we look at these values a little bit more closely, and, we could zoom in even further on this for our purposes here. So, like, let me go over to where we're specifying the zoom. So in here, let's say that we want to keep this span around for a little bit, but I'm going to go ahead and zoom in like way in for a second just to visualize this more carefully, right? All right, maybe not that far. Try that one more time. So what you can see about this is I'm expecting, or was expecting to see, a 10 by 10, right? And if I look at the red, I see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9-ish. I mean, 1, 2, 3, 4, 5, 6, 7, Yeah. I think you could make an argument pretty easily for 10 there. You know what? These are from -1 to 1, though, so I guess I need to do this. So maybe that's all that was. Hold on 1 second. Am I wrong about that? Right, these are -1 to 1, so if I undo that transform, that doesn't look right at all. The green is like full bright. Oh. Yeah. Sorry about that. All right, so if I look at this, right, what I'm trying to say here is I see this value looking like what I would expect, so 10 across, but this is not looking at all like what I expect. And so I've got some kind of a bug in there, I'm not understanding what's happening with like the TY value, and I'm not sure why, right? And pun intended. And so I need to figure out what's going wrong there, and it could be that this packing here is wrong, and it's kind of a mess, so I could totally see that being the case. So maybe we need to take a second and actually figure out what the heck we want to do here for writing into these packed versions a little bit more cleanly. But it really looks like we've got the Y wrong, because our X values line up exactly the way I would expect them to. And our Y values totally don't. They look doubled up. So it looks like, for example, if I had to guess, it looks like we're advancing the wrong amount for the next sheet or something. So basically, like we're not going where we should go for any particular cell, right? So if you look at what we're doing here, this L-index C is supposed to pick out like a particular pixel. So that has to be able to map directly from a particular voxel location into where that would go in the texture, right? I mean, that's what's supposed to be happening here. And we don't have to care about L-index D at all because we're not debugging that texture, and it's just the exact same lookup with a different variable anyway. So I think what we want to do here is figure out what this equation actually should look like and try to make sure that it's actually right instead of being kind of messed up, which appears to be at the moment. So if we take a look at what our parameters here actually are, these parentheses don't really do anything, right? So this is what we're actually looking at. These are our actual, parameters. And if you look at how much we're going for each sheet in Z, we're basically saying, look, we're doing one entire voxel sheet times the size of each of the light maps. And that seems like it makes sense. For Y, we're going, let me rearrange this. So for a Y voxel sheet, we're moving down essentially, that's saying we're going to move down one complete dimension's worth of little squares, right? Which also seems reasonable. For X, we're moving by this dim. And that... I'll be honest, this doesn't really make correct sense. So... No, I mean, I guess that does. I mean, Yeah, it does. So basically, like, we start out moving by just however wide it is, because for each X voxel, we have to go one whole sheet, right? And the TX there is, that's moving by pixels. So we go up one level, and we now have to move by whatever the dimension of the voxel is, but we also have to move by the dimension of the actual squares, right? So you're gaining like both of those on the voxel side of things. I don't think this would have to do it because we're not packing them that way. For TY, we need to move down by whatever the dimension of the thing is times the hot dim as well, right? I mean, that does make sense. For each pixel-wide wise one we need to go. So that does seem right. But again, no, you know what? It's going to be this dimension is going to be sort of wrong because you still have to move Yeah, you know what? I'm just looking at it, I still don't see the bug there. I mean, it looks all right to me. Because another way to say this would just be, look, this is the amount we're moving in Y. We have to compute a Y coordinate and an X coordinate. The X coordinate is going to be obviously just like if you're trying to move a pixel at a time, which would be this, then it's going to be unadulterated. If you're trying to move a voxel at a time in X, we're just saying that, well, that just happens by you going 10 pixels over, right? So as far as X motion is concerned, we are literally just talking about this, right? That's how we move in X. And so anywhere that you ever want to be X-wise is literally just that. There's nothing else that happens in X, right? For Y motion, we kind of have a weird situation because Y motion is actually going in X, in a sense, because Z is how we laid out our sheets. So in order to move in Y, there's two things you have to do, and because the actual squares are laid out in the UV as a square, it means that when you move a pixel Y, you have to actually just go by the entire length of the texture, right? And so I think that's the part that's a little confusing. So in order to move the entire length of the texture, well, Z moves by the entire length of the texture by using hot dim times octdim, right? The entire length of the texture is going to be the X times the Y times the octdim, right? So it's going to be to move one pixel in Y, you do have to move by the total number that there are times how many the size of each one to get one Y over, and you're going in X at that point, right? You're going laterally. And then in order to go an entire Y sheet's worth of those, like TY, yeah, so the part that I'm having trouble wrapping my head around, so TY actually needs to be doing this totally differently. Like, this is not... This is still not correct. Let me just make sure I got this right. So This is definitely correct. This is moving by the number of those that are on one entire X sheet, and it's moving that number over. That is wrong. So this is the part that's wrong. The reason it's incorrect is because there are many Y's next to each other, and we need to account for those. So actually, this would only account for the number that there were in X. So that is actually what has to happen, right? It needs to account for the number there are in X and the number there are in Y. So yeah, I believe that's actually how this needs to get encoded. And, well, actually that's not true. So I believe that's the first part of how it has to get encoded, right? That has to happen. That's how you move in TY. If I nerf out these for a second, because I want to think about this separately, I'm curious, is that now actually at least properly stepping through? And I don't know, how would I see that? For some reason, I don't see, this doesn't seem to be changing at all, which seems odd because given the fact that I'm manipulating how we're writing these out, I suppose that may be because it's writing to a different area or something. So let me restart here and just see what we get. We should get like nothing or something, right? Yeah. I'm going to take the whole vspan just so I can see where that's writing now. All right. And so now I'm not seeing anything on here. I'm going to try the upper corner of that as well. So when we're looking in here, I'm going to look when we take the UV span. When we take the UV center, I'm going to reset the UV center to be like the UV span, like so. So this would take the corner of the texture, the min corner. All right. And so here you can see writing into the texture. And now, by the way, it looks correct, right? So if I zoom in on that now from where we are, I'll go back to the zoomed version. And it's only writing one row, which is how many I thought it should write. Now we can see that we're actually writing, our indexing is correct to this thing. And so then if I go in here and say, all right, how do I start extending this out to more of these so that I can fill the next row? I've got to make sure these things are indexing correctly. So let's start with Y now. And remember, no matter what I do to Y, in theory, I should not be able to fill in another row because Y exists on only one row. So each time we move in Y, I need to go hotdim times octdim over, right? And this, I think, is wrong because this is not part, right? Like, think about what this is doing. I'm saying I'm stacking these in the Y direction. I'm sorry, in the X direction, so that I have one row and then the next row is just next to that row on the same row, right? So even though these are multiple rows logically, I'm packing multiple rows together. So I don't actually involve this part at all, right? Moving by the voxel just moves by however many of these things you had to do to get to the next one. So we're still going in Y at that point, and we don't square our X pixel value like that. Oops. So now if I look, I should still have the same thing, and I do, which is actually good. And so now all we need to do is move in Z. And so Z is the first time we're actually going to say, look, all right, we need to move. We know that each row is hotdim times hotdim long. And we also know that we need to skip over the octdim times the octdim because we are moving by entire squares now. So I think that's the entire equation. That was a real mind bender. It shouldn't have been, but it was, just because I'm not used to packing a voxel into a square like that. And so that looks much more valid. All right, so now if I go back, thanks to our structured art, we've eliminated one of our problems here. Now if I go back and take out the line where we switch UV centers, I can go back and look at the place I was looking at before. And hopefully now I'm going to see the same thing. So now everywhere should look like these little squares, and it kind of does. And that's what we wanted. So now, having gotten that bug out of the way, we can switch back to looking at the view this way and see if we see anything different now with setting our structured colors up here, right? So I'm going to turn this back on and turn this part off, like so. And now I should get something in terms of how the octahedron looks, right? And so if we look at how this is structured, yeah, like, do I think that looks like an octahedral map? I mean, it doesn't obviously not look like an octahedral map, but I'm not really super confident, right? What I'd like to start doing, because it's hard for me to see which part of which this is, I would like to go ahead and make it so that I'm actually going to try to use the correct sampling here. So when we go through and we're looking at Tx, Ty, what I want to do is actually only write into the places where we were supposed to write. So instead of doing this, I'm going to actually do this, right? And that way we will no longer be... let me rephrase that. I want to write only into the interior without using the edge pixels that we left to, because we're going to copy those in later. So when we actually go through these, I want to effectively write into just the narrow part here. So what I wanted to do is say, look, let's create something that only fills in the interior square, like so. And we're never going to touch those edge pixels, right? Those edge pixels are going to be like a totally different thing, right? And I'm then going to go in maybe and add a pass that actually fills them, right? So now I can see what this thing actually looks like, right? To see to what extent it looks like an octahedral map at all. And one of the things that I'm noticing here is just looking at it, it kind of looks like maybe it's sort of like an octahedral map, but it's sort of off. Like, I wonder if maybe the input here is a little bit off. I mean, I'm not entirely sure. I might go in and step it through this code and look at what these OXY values are just to satisfy myself that there's no funny business going on. But it looks a little off. Like, it shouldn't probably have its center line like that. Its symmetry looks a little bit broken. And while the fact that it's an 8x8 means that its symmetry isn't going to be perfect, and that's okay, it does make me a little concerned. So I just want to kind of get that. I want a little bit more assurance that there isn't something busted there before I go any further. I'm going to go to debug mode. In Remedy, I'm going to ask it to stop the code at the point where we're passing down those values, and I just want to see what the ranges of the values that we're passing, right? And I want to satisfy myself that they make sense. So I'm going to go to the watch window here. I'm going to see what we get. So -1 is what I would expect. Stepping through these, yeah, exactly. So I'm missing my last value, right? And I guess I'm not sure. Oh, it's, you know what? This is the problem right there. So I was right. I mean, to the extent that we can call me being right today. I mean, I was wrong when I wrote the code. This is supposed to go up to this value and include it, right? So we want this code to actually still look like it did. That was just kind of an oversight in which values we were supposed to be considering. So, you know, if we're going to the light color lookup square dim -1 here, we would need to actually include that value if we ever wanted this part to actually work, right? And so I think that means this needs to subtract 3, right? It needs to subtract the 2 that we've pulled off the edges and then 1 because we want to divide out to 1 exactly. And so I think that's what we need to do in order to get this lining up. I think, right? And that's starting to look actually a lot better. I know it looks a little worse inside here, but it's more symmetric now, and these are going to be rounding error issues anyway in here. I'm not super concerned about those at the immediate moment. This is starting to look correct because these blue parts here, right, just in terms of how this is set up, the way that we probably want to try and color these a little differently, I guess is the way I would say it. Because the way the octahedral mapping works is it's going to have, you know, things based more on whether or not x or u plus v is greater than 1 or less than 1 to say whether you're on outside of the octa. So it's not going to produce an octa. It's going to produce more like this checkerboard that we're actually seeing. So that's actually fairly encouraging. All right. So I'm going to go ahead now and verify that I can actually produce sort of an octahedron. So what would we do here if we wanted to actually produce, you know, an octahedron? Let's start by switching between the the sample direction 0 and 1 case, right? So let's say that our light color is going to be, you know, if we're on the top of the octagon or the bottom of the octagon, we're going to set our blue channel to 1 or 0 or something, right? So I'm going to get rid of this for now. And I'm going to just set the sample, set the light C equal to positive or negative there. And then what I'm going to do is say, look, let's see which of the X quadrants we're on. Let's see, how do I want to do this? Yeah, I mean, I think I can set these to just be, you know, I mean, I guess what I'm saying is, can I just do this? Can I just look at my quadrants and take a look at the light that way? Because that should give me something roughly resembling an octahedral map, and we'll see where it goes. So if we take a look here at what we're filling in, you can kind of see that it's a little bit wonky. So, you know, we've got something that roughly resembles an octahedral map, but it's not quite. So the actual sample directions here, if the X was positive, maybe I should have done it this way. So yeah, we take a look here. If the X was positive, we're going to see red. And what we're seeing here is that for some reason, as we get up to the top, the X is not positive. And I'm not sure why. Is that because the X is 0 there, you know, perhaps? I suppose we can figure it out maybe by doing that. just to see what we get there. Yeah. So basically, like, the x is positive. What we're seeing is, like, the x is positive here in the octahedral map, but also all through there and here. And I'm not sure that that's correct. If I remember correctly, the way that, like, you know, if we just looked at the blue, you know, like, let's suppose that we made it a little easier on ourselves and knocked out the red and the green. If we just looked at the blue, what we would expect to see is only this part would be in and the outside part would all be out, basically, right? And that looks correct. Like, that seems right to me. So that part of the octahedral mapping, I mean, seems right to me. For the other part of the octahedral mapping, let's just take a look at the x. So now what we're saying is this is the x side of the cube. And I don't know that I believe that those should be set like that. The x is 0 through here. So I guess maybe that's okay. Like, we're saying that's actually equal to 0 literally, right? So I guess I might believe that too. And now if I go through and just say, like, x and z, if I take a look at the y, I would expect to see the same thing, basically, like this top part. Yeah. So I could believe it. I'll be honest, I could believe it. I could believe that we've got it going now. I don't want to say that with 100% confidence, but I'm willing to believe that's more or less a correct octahedral map at that point. So let's go ahead and turn back on our actual lighting so that we can see what it looks like now that we've done that amount, that limited amount of debugging. And we'll see how it goes. There we go. All right, so why can I not? Oh, because we're in debug mode. My bad. Debug mode is very slow still because entirely of the lighting code. All right, so now let's go ahead and take a look at how these maps look. We may have to zoom out a little bit now on them. And I'll be honest, that looks a lot better, right? You see it kind of moving around sort of as if a light source were unwrapped into that octahedral map. I mean, I feel just a lot better about that in terms of the likelihood that now we're actually mapping the octahedral properly, right? I mean, I just feel much better about it. I think, you know, I thought there were bugs in there. There were. Now it's looking a lot less like there's any bugs. Like, that doesn't look super buggy to me. I'm going to pop out a level here of zoom on the, so you know, go back to maybe sort of the further up, looking at a larger cross section of the map there, and just see if that seems to continue to make sense. So, you know, I'm thinking that's not bad. I'm thinking that's not bad, right? I'm pretty happy with that. Let's go ahead and go to a quick Q&A, but I think we're good for today, right? Am I right on time? So wait, what would we start if we start at 12? No. Wait, we've got more time. What time do we start here? 93 minutes? Okay. No, I've got more time. So great. So let's go ahead and finish up the writing side of the code, and because now what we should be able to do is go in and do our copy, right? So we should be able to do our copy back where we say, look, let's just take those corner pixels and copy them in. The other thing we could do is actually use the lighting now, which I guess we could do. Maybe we'll throw that in because we have a little bit of time. Maybe we'll do that. If we take a look at what would have to happen there in our ZBias program, we basically need to do the same stuff that we're doing in the main app, right? We need to be able to sample the lighting in the fragment shader, which is going to take a bunch of work, right? So if we take a look at what's going on in here, and I really wish we could see this as actual code, regular code. It would be nice. I feel like we could probably make that work in 4Coder at some point. But basically something where we could just say, like, look, just indent this like normal code, right? Like, take a look at what the value is here, and we could say, hey, 4Coder, if you see a here doc that's basically that, right? Indent it normally, because it would help a lot, right, for us to be able to read this stuff. And there's no reason we can't just do it that way. It's just a question of 4Coder just needing to know that, which I don't know if it's possible or not. I don't think Alan's watching today, but I do feel like that's something that would be cool to have at some point. Yeah. Anyway, so if we take a look in the main code here, what's going to happen is we do a sum light call to get the lighting, and then we multiply by that lighting. And if you look at what happens to the sum light call, we just don't do anything currently, right? Nothing happens. Now, we know our voxel UVW and our relative position in the voxel and all that garbage, right? So we basically know how we would go about starting to look up this stuff. But what we don't know at the moment is like how we actually would go about taking a voxel sample for each of these. And what we're going to have to do, right, is we're going to have to produce our own manual sampling of the, we're going to have to take 8 samples ourselves and blend those 8 samples together. Now that's not horrible or anything, right? It's not bad that we have to do that, but that is what we have to do. And so if we go in here and start to do that, what we would need to do is find what the 8 corner voxel locations are to sample between. And in order to do that, we would take this voxel UVW, multiply it by the number of voxels per side to figure out where we are, right? So when we take the voxel relative P and multiply it by the inverse dim, what we're going to get is like something where we want to basically do like a floor, a multiply by the size and floor to figure out what voxel cell is like the bottom corner of us. And then we're going to want to find the like upper corner and so on. Now, if we just pass the voxel dimension in here, which we can do, right? Like we can just do a pound define for this. Right, we can just say like pound define light lookup voxel dim, and that's just a a value. We should be able to multiply to find what those voxel parameters are, and then we should be able to take those samples using like a utility function. So if we want to in here, we should be able to say something along the lines of, all right, voxel, address or voxel I or something, right? That's just going to be whatever the UVW was times whatever the heck this thing is, right? And I guess since we're in shader land, we can actually just do a straight multiply like this, and it should just work, I think. That gives us the actual voxel index. And when we have the voxel index, what we want to do then is find the corners, right? So the corners are pretty easy to understand, right? They're just like this sort of thing, right? So we've got that oscillating down, and if we just pick out each possible additive permutation, so going 1 in X, 1 in Y, and 1 in Z in the voxel, if we just do all the permutations of that, that's 8, right? 2 to the third. We get 8 permutations. Those are the 8 corners of the voxel that we need to look up. We've done this before. It's nothing special, right? So if we want to take our light samples at each of those locations, then we need to actually have some utility function that's going to take a voxel index, look up where the light actually should be, and give us back something we can actually use, right? Now, because we're going to want to look up 2 things, we're going to want to look up a depth and a color, and we want both of the things, we want them both to come out. I'm going to go ahead and say we probably just want to do something where we actually call the sumLight function. We want to call like a function on each of those. So like we want to do like a like an accumulate call or something like this, right? Like we want to be able to do something where we're summing up these as we go. And what we're going to use here to figure out where in the voxel we actually go is going to be like a voxel lookup UV that's for the actual subsquare. And that's going to be based on the normal we're trying to sample. We don't want to unwrap that every time. So we want like an octahedral, we want to do that unpack at some point. And we're going to want to pass that into the accumulator so that it can sample based on the direction it's supposed to actually be looking. You know what I'm saying? It's like, what's the lighting in that direction? And I think that's mostly all this would have to look like, right? And so each of these is going to want to do a sample into the voxel. It's going to give us back like I guess we could do the accumulation here, where it's just going to give us back whatever the lighting was from that thing, and we're going to multiply it by some weighting value, right? Like we're just going to be doing like, well, what's a voxel? It's one of, if we're summing these things together. Oh, well, no, we're not. We're going to need to do the trilinear blend, now that I think about it. So we're going to actually want this to be getting the values out of these from a trilinear blend. It's not going to want to do the accumulation. Now, there's a slight issue here, which is that when we're doing the blend, I'm not sure where we take the depth into account, because we'll have that depth and we'll say, I guess, could we have seen it or not? And, I don't really know. We should probably go back and look at the original paper for how to do the sampling there, what they think a good way to do it is. But I'm trying to figure out how this code should work. Ideally, what we would do is we'd get back the depth. We'd get both of the things. I'm just not sure how you actually structure that in a shader. Like in C, we'd just create a struct and we'd return it. In a shader, you can sort of do that, but I'm not sure to what extent you can actually do that. Oh, duh. You know what? We'll just use a V4. So do RGB and we'll stick in the A, we'll stick the depth. That way we don't have to worry about, can you declare structures and shaders in GLSL 3, which I don't know if you can. Eventually, in later shader versions, you definitely can. I just don't know about 3. All right, so we'll just say like this is sample S000, right? And this way we can just write down what these are. So we're saying like, look, it's something like this, I guess. So we've got all the samples coming out that way. And this will just be like, so we'll get all the lighting out that way, and that'll be a fairly simple lookup. Once we have the octahedral unwrapping, it's basically just figuring out where in the voxel you are, or where in the texture sheet you are, pulling out the value and giving it to us. That's all it has to do. And it can do both of the samples and pack them together. And then all we need to do is actually do our lerp. So we have our vox UVW here. What we don't know is where you actually are in it. So when we actually do this light lookup voxel dim times the UVW here, right? This thing, when we do this vox I, we want to floor that, but we also want to know, you know, so I guess this is actually how you would sort of do it, right? We would get the IVEC3 out of that, but anyway. So we want to floor that, and this is actually going to be, we want both of these. So we want to store what the offset was, like where we were in the actual texture there. And so where we were like in the actual voxel. And so I'm going to like call this like vox relative or something. So we then would say vox r, you know, minus equals vox I. So that way we have the relative coordinate and the like absolute coordinate. So we know like the fractional part and the non-fractional part, right? We'll put the unwrapping here. When we do this, we'll have the information we actually need to look up into the light location, I would think. And we can probably do this in a better way because these would all be fixed offsets. So we can probably just compute those offsets ourselves and speed up this routine. So this is not going to probably be the way we want to do it eventually, but just to keep things a little bit simpler. And then we'll actually do the blend here. So we're going to call this the result. We'll return this result. And here in the result call, what we want to do is actually take all of these values and blend them together, right? So it's going to be one of these heinous lerp sorts of things, but we can do it sort of in stages, right? So we can take and create some interim values here. And I don't really remember, did we define the lerp ourselves? I don't even remember how we did this stuff. Yeah, we did. So we made our own lerp ATB. So we can just go ahead and write this the way we would normally write it because we made a macro that turns it into shader speak as necessary. So we can make these lerp, and basically what we're going to do is remove one dimension each time. I mean, that's all we're doing here, right? So S000, we want to remove the variance on Z. So we've got two, right? And in each one of these is just going to do... each one of these is just going to do one of these, right? So that would remove one dimension out each time. And which dimension are we going to use, right? So, well, it's just Z. So we know that the vox RZ is the value that tells us how much Z we should blend, right? How much we should blend to the next Z one. And then we can do the same thing to take the last dimension out of it, right? So now we've got the same thing. We've got, you know, 0, 0, and 0, 1, and 1, 0, and 1, 1. And that would, you know, be removing the Y dimension. And then the final one for the light sample is just blending those two together on X. And then we've got our result if we want it. Now, eventually we're going to want to do more stuff here because we're going to actually want to do the reflection probably in a smarter way, or, you know, whatever, the diffuse blend and all that nonsense. So I don't know exactly what we're going to want to do here with respect to that. And if we look at how this is working, right, so this is the reflection vector, but you know, if the surface is very diffuse, it's just going to be reflecting general lighting. So we may want to also do some things where we control like the MIP sampling of this thing. So we've got a bunch of stuff we're probably going to want to play with. For right now, though, let's just say we're going to take the reflection vector and we're going to unwrap it and use that for the lighting. So we would need our octahedral where we say, look, we've got a unit vector and we need to put it into octahedral space. So we're effectively going to have to do this, right? Now, in order to do this, we don't have to do it as badly as we were doing it before, right? We can actually be a little bit more clever here because we have the ability to do like swizzles and stuff. So instead of having to do the stuff we were doing before, we could do this more compactly if we want to. So first of all, we can do here where we say like, here's the oct, right? So we take the one norm, that's going to be taking the R vector. And then we're going to say, all right, let's go ahead and divide that out. That gives us effectively the result. So that's what we wanted. And then all we really have to do is say, oh, well, though we do have to do a thing where we take whatever when the z is negative, right? We have to then say, okay, let's update the xy to be equal to this equation, right? So then what we need to say is, all right, if the z is negative, we're going to have to take the sign of the thing that we were talking about before. And it doesn't matter which sign. The signs will be the same because this won't change the sign. So we can take the sign either of oct or of r. I don't think it matters which one. And so maybe we'll take the sign of r. Might be the better way to do it. And then we want to take the absolute value of the octahedral sample. So that should be oct, I believe. And this should be what we actually want to produce, right? So we want to take the absolute value, and then we want that sign of. I don't know that we have an ability to do sign of in the way that we would need to, right? I'm going to put this back this way. Sign of, in this case, is supposed to produce positive or negative. It's never supposed to produce 0. And I don't actually know what the definition of sign of is there. Like, I don't really know what GLSL defines that to be. Like, what is it? So if we look, yeah, like sign of doesn't really help us because, or the one that they have, the sign call will incorrectly produce 0 when we didn't actually want it to do that, right? So I guess we will have to implement that ourselves. Unfortunately, I don't know. And we can look, in fact, I think we actually saw this. If we go back and look at the actual values that were, in the reference version. So we downloaded the light probe part here, and in the supplement, they gave the code, right? And the code for the octahedral wrapping and unwrapping, was it in here or did we, you know what, I think we maybe had to look it up in, yeah, I think we maybe looked it up in here. Yeah. So this is how they implemented it, right? And if you look at what they did, you can see that they had to write this themselves. And so I don't think they would have done that if there was a convenient, if the GPU actually had a call for that thing. I don't think they would have done that. So my assumption here is that we just have to write it ourselves, right? Because it doesn't look like there's any way to do it otherwise. So they need like sign of, you know, we need to do it ourselves, like this. And I think that's just the way it's going to have to be, right? So I don't know if they've got sign of, if we define sign of in here. So we have sign, and we define that as sign, and our sign of is not that, right? And it doesn't work the same way. So we kind of need that to be like, this is actually sign or 0 in a sense, and we don't really want that. So let's see what else we got here. All right. Let's try to debug that shader. We got a few minutes. Actually, I guess we don't really have any minutes left, but let's just try to get the compile errors out of it. How about that? So let me go ahead and take a look at what the errors are here in the program. These will be what? Fragment errors? Absolute value. Let's go ahead and get that straightened out. Sample lighting. That's true. We haven't done that yet. So here's sample lighting. Maybe something like that. Seems reasonable. I'm not sure what we're actually going to put in here, but I suppose right now, if I just stuff it with white, we will at least not ruin our rendering because it'll just light with nothing. All right. What else we got? Undefined variable vox I. Is that true? That is true. I agree. All right. And so now, in theory, we've actually got this set up. And so tomorrow, we'll go to Q&A for now, but tomorrow we should be able to move over into actually sampling these and seeing what we can get out of them. Pretty happy with that. We're in good position. We had a bunch of bugs. I knew there were bugs. We got rid of them. So we'll be in good shape to like get some more bugs out tomorrow, because now we're gonna have to get the lighting sampling working, and I'm sure that'll be a little bit buggy too. But we'll get there slowly but surely. All right, let's go ahead and go to quick Q&A. Anyone got any? Uplink Coder was asking if I could show the octahedral map with linear blending. Sure. Let me go run it again. All right, so here's an active octahedral. Let's get to a position where it's relatively good. So there's a, there's an octahedral map area. You can pretty much see that it's, doing something probably correct. I mean, I'm not confident that we completely debugged this thing yet, to say the least. But I'll go in here now and I'll switch from, over to the linear. So if we go down to how we're doing our filtering, so here's linear in a second. There you go. And you know, there's not a huge difference, right? Obviously, it just smooths it. I mean, it's pretty small texture, so, but you know, it's exactly what we would expect to see. And we'll switch back. Can you say a few words about octahedral mapping? There's not a lot to say about it. If you just go back and watch the streams where we implemented it, it's pretty easy to understand. But I mean, this is the diagram. This is it in a nutshell. It takes a sphere, it maps it onto a square. You can think of it as first sort of shrink wrapping the sphere onto an octahedron, so two tetrahedrons, one facing up, one facing down, and then just unwrapping so that the top part of, you know, the part that's facing up, the top hemisphere, comes into this middle part here, and then the bottom part is just unfolded so that it has somewhere to go, right? That's it. Kind of off topic, have you ever been at a point where you thought that programming might not be the right thing for you? Yeah, sure. And I would say I currently think it's not the right thing for me. I really love programming. I think it's awesome, and I love doing it. I still pretty much enjoy anytime I'm actually programming. I would say that doing it as a job is just a really bad idea these days. There's absolutely no interest in the current computing landscape. There's absolutely no interest in doing a good job. There's no interest in trying to make good computers. There's no interest in trying to make good operating systems. There's no interest in trying to make good tools. And so I would say probably 95% of what I do is just cleaning up other people's crap. I get to actually program things that I actually wanted to program so rarely. And it's really, really sad. And so I would say that I don't think I ever really had much of a doubt, and still don't, that I love programming and love doing it. You know, I think you could make the analogy to probably any other industry. At some point, that industry becomes like so distorted and useless that, you know, it's not really about the thing that it's nominally about. And I guess I would say if you loved cooking, but the only way to get paid cooking was to work at McDonald's, then at some point you might be asking yourself why you're doing it, right? Because it's not really cooking. I mean, it technically is. Like, technically, if you work at McDonald's, you are cooking, but you're not really doing the thing that you would call cooking if you were talking about it separately. And so that's the modern programming industry, right? The modern programming industry is all programmers effectively are now working at McDonald's. You know, they like to pretend that they're not, but they are. And so what you're doing is not programming. It's, you know, taking a chicken patty out of a freezer. It's already been fried. You're putting it into a microwave and pushing a button. and you're not even putting in the time. You're just pushing the button that says chicken patty. Out it comes, and you put it in a wrapper. The wrapper is on a stack that you grab, and then you hand it to a customer, right? And so at that point, you're just like, I mean, so yeah, you could try to, and I do, try to then say, all right, I'm going to go spend the time to build my own, like, I'm going to go learn to be a carpenter so I can build an actual place that's not a McDonald's. And then I'm going to figure out how to build like a stove and put that in there and like all this stuff, right? And start a farm to actually make the ingredients so that I can actually then cook again, right? And, I tried to do that, but at some level it's like kind of a bit Sisyphean. And at some part, when you're right in the middle of it, you kind of go, why am I doing all that? Like, I don't really want to do all this stuff. I don't want to write an operating system, or I didn't really want to write a standard library or something. Or I didn't want to, or in case of, someone like Jonathan Blow, it's like, maybe he does enjoy making a language, but sometimes it's also, why the heck does he have to make a language? Like, he's not even one of these, he's like the greatest game designer of all time. At least certainly from my perspective. The dude's got to make a programming language. Good on him for doing it, but come on. How much wasted intellectual power is going into this stuff because the people who were supposed to be doing this stuff just didn't care, right? Or suck. And so at some level, it's really sad. And so I definitely feel like I'm in that place, and I am not a game designer or any of that stuff. So it's not like my talents are being wasted like they are with John's, maybe. And waste is the wrong word because he probably will design a cool language, but it's like a ton of potential. There's a ton of games you won't play because, the people who make all of this stuff suck. And John's spending his time figuring out how to do stuff like get Visual Studio to install properly and replacing the programming language. You know what I'm saying? And so I think it's a really depressing time to be a programmer. It's horrible if you actually care. It's a great time to be a programmer if you just want a job, because there's a ton of jobs and they pay really well. So if all you want to do is make some money, it's a great time to be a programmer. If you really love programming, it's a terrible time to be a programmer. That's how I'd say it. Have you ever used or heard of spherical Gaussians before? I have heard of them before. I've never worked with them before, which is exactly the same as spherical harmonics. So my understanding is spherical harmonics versus spherical Gaussians. The difference there is basically what's the basis function that you're going to apply to the sphere to project your functions on, right? So you have some lighting functions. Usually they're discrete, so it's calling it a function maybe is the wrong word. But you have a lighting set of lighting samples, and you want to project those onto the sphere and potentially compress them. Spherical harmonics are, Fourier style. So they're going to be like sine, cosine, lobe shaped things that are defined over the sphere, right? Spherical Gaussians, although I've never looked at them, I assume are just Gaussian functions on a sphere, right? Because why not? You can use any basis function you want. They don't even have to be orthogonal, right? You can define anything you want as functions on a sphere, and you can decompose functions on the sphere into those basis functions. So my assumption would just be that that's what they are, but I've never looked at them before, so I don't know. I wouldn't be in a position to talk about trade-offs between, say, why would you use a spherical harmonic function instead of a spherical Gaussian function, because not having worked with them either myself, I just don't have any intuition for where they go wrong. I'm sure there's reasons why you would use one or the other, otherwise you wouldn't have them. But I'm the wrong person to ask. I remember we moved away from manual trilinear filtering on voxel samples because it was a lot of texture bandwidth. How is this better than the old approach? So actually, this is really pretty interesting as an approach. I'm pretty excited about it. So if you remember correctly, we were previously saying that we had so previously we're saying, look, we're going to have 6 textures, and each of those textures we're going to have to sample ourselves, right? So we had each of the 6 directions was sort of, I think, what we had stuffed in there. And it's a lot of texture bandwidth to blend those first and then look at the results. It wouldn't be a lot of texture bandwidth to just blend the thing first and produce one vector sample and then return it, right? But even doing that would have required us to sample at least 3 of the directions and blend them together. The thing about octahedral sampling that's so nice is the texture card does that first blend for you. So imagine you're going to do one trilinear blend. Well, you know that's going to be 4 lerps, 2 lerps, 1 lerp, right? Now, if you had to do that on 6 directions, that's 6 times those 7 lerps, right? 6 times 7 is way too much stuff. On the other hand, if you blended first, well, now you still have to take at least 3 samples of each of the voxels, blend those together, and then do the 7 lerps, right? And so you still have 3 times 7. With the octahedral sampling, it's just 1 times 7. You look up and you let the bilinear blend do the lerp, do the first smush down for you, right? So it is very nice. It takes out one entire step of the process for us, which is great, both in terms of making it simpler, but also in terms of less work, like less actual GPU work. So it's faster too, I would think. Do you think step x times 2 minus 1 could be faster than our current sine implementation? I would seriously doubt it. I mean, you know, I'd have to think pretty hard about it, and obviously you'd want to time it if you actually cared about the performance of that particular thing. But, you know, if you take a look at where was it, ZBias program here. If you take a look at what we wrote, so that sine of function, right, is compare and then select. So you're talking about 2 instructions to implement this, whereas what you're talking about is 3. It's at least step, a multiply, and a subtract. So pretty sure it'd be hard to beat this. Is there a reason you think step times 2 minus 1 was faster? Maybe I can answer it better that way. Why is the depth not red squares? I think that's just because we haven't actually touched that part of the routine. I can go ahead and fix that for you if it's bugging you. I don't mind. I agree that might be kind of annoying. So if you take a look here, you can see we've got the original set of vertex stuff here, and then we've got this one. I didn't really look at what this was set to. It looks like it's drawing in the right place, so let me just see if we got the UVs set up correctly here. Looks like we do. So I don't know if it's possibly a problem where we didn't submit the texture properly or dimension it properly. I'm not sure. We should look at that because this looks like it's 16 by 9 again, which suggests to me that something's a little off, right? But I don't know. I'd like to look at that a little bit later. If you don't mind, I'd rather not get into it now because but yeah, we would like to fix that. It doesn't look like there's anything obviously wrong, so I think it's probably there's probably something broken about it, right? I think you just didn't apply the fix. Oh, right. That's a good point. We're not actually writing into it correctly yet, are we? So we wouldn't expect it to be right. Like this. Oops. So this code here, right? This is correct, but this is not. So I'm assuming that if we just did this, maybe that would be sufficient. I don't actually know that that's true. I mean, we might have other problems in there. But yeah, if we just change it to octdim here. That might be all that's wrong. I don't actually know. So yeah, I think that was all that was wrong. Since we don't write into those pixels, yeah. So that was it. Thanks for reminding me. Yeah, that we're not writing anything into there yet, but we were using the indexes wrong. So even though we were just writing red, it was incorrect. Do you have any opinion on potential new computing devices or platforms, i.e. mobile operating systems, tablets, multi-screen devices? Is there anything interesting going on? No. I haven't seen anything interesting. If anything, it's less interesting because they're devices that are made to be more locked down usually. What do you think of Carmack working on general AI? I don't really have a thought on it. I mean, Carmack's even older than I am, so at this point, I feel like at the point in the career, at the point he is in his career, I mean, you know, how much programming do any of us have left? He should just be doing whatever he wants. So I think if he's interested in doing AI, that's what he should do. I mean, he should do what's interesting to him, you know. I mean, he's already, you know, made a bunch of significant impacts on the world, not just the programming industry, but, you know, I mean, he's more than made his mark. He should just be doing whatever he wants. Yeah, if he likes it, he should be doing it. Some people already mentioned this, but it'd be cool to see more handmade chats, talks with guests, etc., similar to the data compression talk with Charles. Yeah, I do agree with that. I probably wouldn't do it, though. Is the bilinear sampling from the octahedral map exact then, or is there some distortion due to the way we are mapping the sphere in 2 dimensions? Yeah, I mean, of course, there's a distortion. The distortion is specifically the projection. It's the projection from a sphere to an octahedron. So I'm not sure what you mean by that. I wouldn't necessarily say that the bilinear part specifically is a distortion, because it's hard to claim that the bilinear in particular is distortion, but just the map itself is a distortion, right? So by definition, the octahedron itself is undersampling certain parts of the sphere and oversampling other parts of it. And, you know, I don't know that there's any particular reason why you would blame the bilinear for being somehow worse or whatever, right? Would you ever consider doing a tutorial on testing for something like a library where it's important to be thorough? Yeah, I mean, there'll probably be some parts on testing in the course when I release the course. Math Damon says, I thought ours might be scalar, but was just a guess. I thought ours might be scalar, but was just a guess. I don't know what that means. I thought ours might be scalar. I'm sorry, I don't know. Everything in this shader is scalar, so I'm not sure what that means. Kniffle says, what other than the games at Molly Rocket are you working on, referring to the cleaning up other people's mess? You said earlier, maybe I misunderstood. Well, I mean, but everything, right? So anything you're doing today when you make a game is cleaning up someone's mess almost exclusively. Like the amount of time you spend on the game is almost zero, or vanishingly close to it. I mean, it doesn't matter what part you look at, it's someone else's mess. You have artists. How do they make stuff? Well, like in our case, they make it in Photoshop. Photoshop's a complete disaster, loses most of the information you would actually want, but there's not much we can do about it. It writes out a file format that's garbage, that doesn't have a lot of the stuff that you actually need. It doesn't really allow you to cleanly annotate things. So all of that stuff is stuff we have to work around. We work on file systems that don't properly track changes. So I have to write tools that do all of that work. You don't have any way in most things to cleanly like set up, servers or stuff like this. Using shared drives on networks don't work properly. We have to keep our machines disconnected from the internet because otherwise Windows 10 ruins them all the time. Our Wacom drivers, I had to recently figure out how to get Anna's machine to stop pausing for several seconds all the time. It turns out it's because Wacom drivers are trying to spy on you now, and they send information back to HQ, and of course our machines aren't plugged to the internet, so that was causing a stall. I spend all my time working around the fact that nobody makes anything that doesn't suck anymore, right? And, eventually someday maybe I'll have made enough stuff that and in some cases I do, I do think we've made some progress at Mali, for example. Like nowadays I'm completely insulated from anything Microsoft does. Like it doesn't matter what Microsoft does. Microsoft could completely crap up everything now and it would be okay. We don't use their SDKs. We don't use any parts of their IDE. We don't even really need their compiler, although we can use it, but we kept like an isolated copy so we don't update it, right? And so I'm working on getting us to a point where less and less things are important. But it's hard, right? And so most of the work that you do nowadays just does not involve programming a game. It's working around all of the disastrous crap that has been crapped out and is getting worse by the day, whether that's Photoshop or Windows or the compiler or, the debugger. Thank God, George wrote a new debugger. Otherwise, I don't know what we'd do. Probably I'd be writing debugger right now, right? It's that bad. And the editor was the same way. I had to write my own editor basically. And, thank God Alan made 4-coders, so I had something to start with, right? But it's ridiculous that that's the case. I mean, it's ridiculous that Emacs is what it is now, right? And I had to switch from it because it's such a pile. Quickshift says, StepX might be hardware accelerated. It works on V2 and is branchless. Not sure how impactful it actually is. So I think I would just take a second to say you're probably not thinking about shader code properly at that point. So first of all, everything in a shader is hardware accelerated, right? So really what we're talking about is what is it doing? Nothing works on a V2. There's no such thing as V2s on a GPU. What a V2 actually is just two scalar ops, right? And so it's important when you're looking at scalars to understand that scalars themselves are not... So a GPU goes wide by looking at multiple pixels at a time, or multiple fragments. It doesn't go wide by working on vectors, right? So when you say V4 in a shader, it's not operating on a V4. It's 4 separate scalar operations. One for the X, one for the Y, one for the Z, one for the W. And what's happening is it's doing 16 or 32 of those at a time because it's doing 16 pixels at a time, or 32 pixels at a time, right? So there's no such thing as something that operates on a V2. It's all just scalar code, and it goes wide by going pixel wide, right? It's not operating on a V2. That's no such thing. So what you're trying to do is minimize the number of actual operations that have to happen. It doesn't matter how wide they appear to you because shaders are always full width. They never go under the width of a 4x4 fragment or a 4x4 fragment block or whatever they're doing, right? So take that one part. The second part where you say branchless, again, doesn't really apply to shaders. So the way that shaders work is they're predicated. There are such things as branch testing in shaders, but they're only to test around large blocks of code and only if none of the things that are being processed go through that block. So if you have something where you're either doing one thing or another thing always, so every possible thing that goes through this code will either get a -1 or a 1 based on the value, that is always branchless anyway. What it will do is it will say, here's the values for the one thing. So 1, 1, 1, 1, 1, 1, right? Here's the values for the other thing, -1, -1, -1, -1. And all it will do is say, issue the comparison, which then produce some mask value. And the mask value just says, all right, I've got 16 pixels, so I'm 16 wide. For each pixel, I did the comparison and just built the mask. Zeros for ones that worked, ones for ones that, ones for places where it was true, zeros for where it was false, right? And then it just uses that mask to select, right, between the two possible outcome values. So it's always branchless to do the question mark operator, right? All you're doing is just saying it converts it and then does a select on the two values, one for each pixel. So what we wrote is both branchless and full width already. Does that make sense? It's crucial to understand that difference because you don't want to think about V2s as a unit of computation in a GPU because it's not. I think it's important to remember that. Did you get any traction on your 30 million line problem video in terms of people wanting to collaborate with better programming of the hardware directly? From software people, sure, but never from anyone hardware side. I enjoyed your talk on API design, but I see that it's 15 years old. Have your thoughts changed? Or is it still the model you follow? Yeah, I mean, I might have a little bit more to say, but honestly, in a rare instance of foresight, I would say that pretty much everything I said in that talk is just right. I mean, it seems to just be true. I don't know if it will ever be wrong because it's just like, yep. They just seem to be fundamental principles at some level. And, you might change a few things about some of them in certain languages where you have access to a few features, right? So, in places where closures or something are more common, you may end up thinking about the flow control part a little bit differently, right? But for the most part, I think that I got lucky, and it turns out that those things are more timeless than a lot of the things that, probably if you look back that I said are probably just nonsense. But that one seems pretty relevant. Where could one find concrete resources on 2D lighting? No idea. I don't really know even what that means. You mean just like if you wanted to apply the lighting equations, but not in 3 dimensions? Are they the same? Is there something different about 2D lighting than 3D? I'm sorry, I don't know. I agree with you that software generally sucks, but do you think you're letting it get to you too much? There's something to say about staying positive, cite the math. Yeah, if I had a paycheck, I'd stay positive, but at least for the time being where, it's very stressful for me trying to manage lots of projects and looking back and realizing that I'm spending most of my time trying to clean stuff up that had nothing to do with what I was trying to do. It's not, I don't really know of a way to stay positive at some point. What are some of the major changes you have made to 4Coder worth mentioning? I'm sorry, I don't know what that means. I streamed when Alan and I were doing the 4Coder jams, and he put in all the changes, like all the changes I asked for that I worked with him on, and I did some of the changes and then submitted them back. There, he did them all. So the new 4Coder has all the things that I had changed. So all the stuff I do on stream now is all in 4Coder now. Like the jumping to functions and highlighting by type correctly and all that stuff. That's all in there now. All the hooks are there. I don't know if the default has implementations in the custom part for all of that, but you can do it. So is it possible to implement the idea of a dynamic language without garbage collection? Sure. I mean, what difference does garbage collection make to dynamism? When is the C course coming out? I'm not sure. Hopefully soon. Like I said, a couple months. Hopefully. It'll be on Steam. You'll be able to buy it. I don't know what the price will be. Like I said, I'm pretty sure it'll be less than the cost of like a AAA game. So something less than $60, but I don't know how much. Can you elaborate on the issue C made with tying type strongly with operations? Yeah, I mean, it's just, you can see it as a problem when you start working with intrinsics, right? Like, if you want to add two things together, did you want a saturating add or an unsaturated add, or a signed add or an unsigned add? Saying that a thing is a signed or unsigned type, well, it's not stored differently. So really what you're saying there is, when I do an add or a subtract, I don't care which one it is because they should be the same unsigned or unsigned. But when I do like a multiply, I want you to do a signed multiply versus an unsigned multiply or something like that. Or when I do a what's the word I'm looking for? When I do a comparison, like greater than or less than, right? It's got to be changed. So like certain operations have to change, or shift would be a better example. So I want to do a shift. Well, you want an arithmetic shift or a logical shift, right? And so it's just not appropriate because depending on the algorithm, you don't know, just because I said I wanted to think about this thing as signed most of the time, well, sometimes I don't. And I would rather be able to cleanly read code without having to put casts everywhere. I'd rather just be able to say, look, this is a signed shift, this is an unsigned shift. That's what I'd rather say. And then if I want to say, default this thing to always using this kind of shift, maybe that is a nice time saver, but I don't like the idea that everything always got tied to the type, because it doesn't actually work that way in practice when you're actually trying to optimize code. I don't know, just it's hard to explain. But how many people pre-order the source code? I don't know. Sendal makes it really hard to figure that out. You have to go in and like spend 7 years waiting for it to like sum up values and stuff. It's not many. It's not. I don't think it's any. It's not more than like 10,000. I'll put it that way. So it's not that many. More than I would have thought. I mean, it's I don't know. It might be like 7,000 or something. It's more than I would have ever thought before the game was out. But it's not like particularly many, no. If Sendal continues to be shady, is there a plan to switch platforms so people will still be able to get it if something happens? I don't really know what to do about it, to be completely honest with you. I might try to move it to Steam. I don't know. It's been very hard to find good distribution platforms. So I really just don't know. I wish there was a better place to. I would like to move it off of Sendal. I wouldn't call Sendal shady. I would just say Sendal is kind of more or less defunct. I mean, they are pretty antiquated now in terms of the features they support. It's just not a good e-commerce platform. So I don't actually know what to do about that longer term. I would like to use Epic Store or Steam or something like that, because that handles distribution much more cleanly. It has a much better downloads. It keeps it up to date for you. Sendal doesn't do that. Sendal can't keep it up to date. It also can't handle huge stuff, I don't know. So, someday I might just knock on the door of the Valve guys and be like, hey, man, is it okay if I do this? Because it's not really a game right now, and I don't really want to call it early access because it's not, right? I only allow the pre-orders because people want to be able to follow along with the source code. And it's not early access. It's not a game that I expect people to be playing right now, right? So, I don't know. But I could ask them to what extent, they could tell me something that it would work there. I don't know. But, yeah. I'd like to move to something better. I just don't know how. And if we did that, it would be pretty easy because I could just issue everyone on Sendal a Steam key to go unlock it on Steam. Or something, right? And I think that would just work for everyone who was able to go use Steam. I don't know what I'd do about people who couldn't, because it's possible that certain people can't get access to Steam who could have gotten access to a Sendal download. But what are the challenges of finding good distribution platforms? I mean, it's pretty obvious, right? I mean, you want an online store to function relatively like Steam. I want to be able to have an account somewhere. I want to be able to buy something. I want to be able to have it installed on my machine and kept up to date automatically. I want that thing to handle taxes properly and payment methods properly, right? Compliance and filing and remittance. That, and then that doesn't exist. Steam is really all you got. The Epic Store maybe to a certain extent, but unfortunately the Epic Store doesn't even run on Linux and Mac is my understanding. I don't think. So I don't care about Mac anymore. Mac's over. Like, I've officially, I based on what Apple's done lately, I've said, like, Apple's over. Like, I will never support Mac ever again. But Linux is an open platform. I think it should be supported, especially on something like Handmade Hero where we're teaching how to program. I want to support Linux. So I want something that runs on Windows and Linux. You can buy something on there. It distributes it out, keeps it synced, keeps track of that you owned it, all that stuff. And that's it. As far as I know, it's Steam. As far as I know, there's literally nothing else. So you can either put something on Steam or you can't. And that's it. And even Steam isn't perfect because Steam itself also doesn't really support an easy way to get into the ecosystem. So somebody who doesn't already run Steam, it's very hard to sell someone something and then just have it download Steam, right? They first have to create a Steam account and go through this process. You really want it the reverse way round. You want it so they can just go to my website, hit buy Handmade Hero, and then it says, all right, you download Steam, here's the download, and what would you like your username to be? That's what you want it to do, but it doesn't have that, right? And so that would be really nice as well, because especially when we're talking about selling other things like, we sell a comic book at Molly Rocket. Well, no one buys comic books with that in that way, right? Like, they don't first open up Steam to buy their comic book or even have one of those, right? So you have the same problem, Yeah, itch.io has its own issues. As I mentioned at the start of the stream, where I couldn't even buy 4Coder today because it said my credit card was declined. And then I called my credit card and they said it had never even been attempted to charge. So itch.io is kind of a bug-riddled mess. I guess I would also say I don't know to what extent itch.io actually handles tax compliance properly, but I suspect not really. The same is true of Gumroad. So Gumroad doesn't handle tax compliance properly. They can't remit. So there's a concept called merchant of record. And basically, if the place doesn't order merchant of record ability, then you just don't want to use them. So Gumroad doesn't, itch.io doesn't, Sendal doesn't. You basically just don't want to use this. because it means that you will have to handle the tax compliance yourself. Now, some places claim to sort of do something for you, like Gumroad and itch.io, I believe, both claim to handle VAT-MOS, and they do, but the problem is VAT-MOS is only one of many taxes that you have to comply with, and they don't comply with any of the other ones. Gumroad in particular doesn't handle sales tax for state sales tax properly. They claim to sort of handle it, but actually it's incorrect. So they violate, like I checked, and their way of handling it violates Washington state law. They don't even know that, but it does. And because there's certain RCW requirements about how tax has to be listed on an invoice. So this stuff isn't a joke. Tax compliance is incredibly complicated. There's very few people who do it properly. If you don't want to be basically breaking the law, it's very hard. Right now, I'm doing most of it myself with Sendel, and it's just not worth it. I'm happy to give Valve 30% to do that for me. Would I love to pay Epic only 15% or whatever it is that they take to do it for me? Yes, but currently you can't. You can't just put stuff on the Epic store. That doesn't work yet. So, you know, Amazon would be great. If Amazon had the ability to do digital distributions well, great. They don't, so it's not really an option. But if Amazon had shipped a quality client like Steam, which it's crazy to call Steam a quality client because Steam's not that good, but hey, it's way better than the stuff that's out there otherwise. You know. So I'm hoping at some point these things get into some kind of a war. I would love to see Steam versus Epic really get heated because I think the quality would go up dramatically, and then I just use one or the other or both for everything, and that would be fantastic. That's not the world we're living in. I don't think GOG lets you put anything up there but games. Does it? You might be able to get permission. The people at Epic who are running the EGS store are good people. Yeah, no, I totally believe they are good people. I emailed Tim Sweeney actually about this a while back. I basically said, like, hey, you guys should do direct e-commerce. Here's the reasons why. He never replied, so probably just went in the trash. I mean, he probably has so many emails. He's not going to bother looking at one for me. No, Steam doesn't have any requirements to put DRM into any program at all. Most games on Steam now just don't even have DRM. I think it's mostly like big AAA games that would, but if you buy an indie game on Steam, I think most of them probably don't even check that box. So like for Handmade Hero, we just wouldn't check that box, right? So, you know, it would just install the source code along with the game, and if you just hit the open local files, it would just open up with all the files right there, just like it is right now, and download the zip. So Steam totally works for Handmade Hero purposes, and I just wouldn't check the DRM box and there'd be no issues, right? It used to be that Steam was DRM'd, and I really didn't like that. They got rid of that, so I have no problem with it now. Like, Steam just works. And anyone can be on it now. $100, right? So I think Steam's great. I wish they didn't take 30%. I think it's maybe a little bit high. At the same time, like YouTube takes 50% and Twitch takes 50%. So they're not the worst, right? So I don't know. And yeah, I give Tim Sweeney like major props for doing the Epic Store, because as far as I'm concerned, like, he really it's just a giant headache for him. I mean, they do not need the money even a little bit, right? Like, Fortnite made infinite money. Tim Sweeney does not have to care about a single dollar ever again, right? But he did the Epic Store anyway, and I honestly, truly believe that he didn't do the Epic Store because he wanted money. I think he did the Epic Store because he really didn't like the fact that people didn't have any other options but Steam. I mean, I really do think that's why he did it. I don't think he did it because he needed the money, or not needed the money, but wanted the money. Because Fortnite, made so much money that there's just, I mean, and he was wealthy even before that. So I really just think, honestly, he did it just to do something good, which is crazy. But I think that's what they did. And so I think that was awesome. I mean, that's like, if it ends up being the case that the Epic Store becomes fairly reputable and people use it and it becomes, more refined and works well and all that stuff, I think it would create a really strong incentive for both Epic and Valve to improve the quality of digital distribution models. And that is awesome because Valve totally was not. I mean, Steam is basically exactly what it was when it started. It just has not had the kind of attention paid to it that it should have had. And I think pretty much the reason for that is just doesn't have the competition, right? I mean, there's plenty of incentive there for Valve to maintain it. There isn't really any incentive there for them to push it forwards and explore all the possibilities and like make great improvements because everyone has to sell their game on Steam, so it just doesn't matter, right? Is there anything on Steam to improve? Totally. Yeah, there's so many things you can improve on Steam. The Steam client itself is very hard for expert users. It's just really obtuse. I mean, I get lost in there sometimes trying to figure out what the heck I'm doing and like where my stuff went. The usability needs a massive overhaul, like a massive, massive overhaul. The purchase flow is terrible. If you don't already have Steam, getting you onto the platform doesn't work. They really need a smooth end user purchase flow. So they need to have it so that if I put up my website and I'm selling Handmade Hero and somebody who doesn't have Steam comes and buys it, it should be like they click the button, it just pops up a little thing, they put in their credit card information just like it is now, then it says, great, here's your download, and you download Steam right there. And it knows what you purchased, and it comes up and has you create the account, right? It should be super smooth. That's not what happens right now. You have to create a Steam account first. You have to use their website for the purchase. It's just, there's so many things that they could do to make it a much stronger e-commerce platform, and they're not doing those things. And again, because they don't have to, right? All right, last question. What are your thoughts on undefined behavior? I think if you have a spec that has undefined behavior in it, then you don't have a spec. Full stop. So like the fact that C++ and C call those things specs, but they have undefined behavior in them, I wouldn't call them specs. I'd call them ideas about how a language might work. I mean, not to put too fine a point on it, a spec should have literally no undefined behavior. And I know that people think that maybe that's sort of an absurd thing to say because, oh, wait, well, what about, when you want to be able to support something like floating point operations, but you don't know what kind of floating point operation thing was going to be, or if you don't know, like, what the kind of hardware is that implements this thing, and so optimization, blah, blah, blah. No, that is not what that means. Undefined behavior is a cop-out where you haven't specified what the programmer can expect when you easily could have. For example, instead of saying that an unsigned 64-bit integer overflow in C is undefined behavior, say when you put that in a piece of code, the compiler will generate the code that would work if it simply did the basic add that the machine normally does, right? Now, it's not overly specific behavior, but it's not undefined. You have defined what the programmer can expect. But whenever you say a behavior is undefined, you've made what is effectively an unworkable spec. It's not a spec, right? And so as far as I'm concerned, if you produce a spec with undefined behavior as a specified category, you're not done yet. I don't consider it a specification. I consider it an aspirational fantasy. Period. Because there's never an excuse for undefined behavior. You can always specify what the programmer can expect. Even if you can't tell them what that is ahead of time, you can tell them how to know when they actually go to use it. Because you can just say, it will do whatever the underlying machine does or something, right? You can always say that. You don't have to say undefined because undefined behavior gives the compiler vendor the opportunity to screw you. And guess what? They always do. Always. Is there an advantage to having undefined behavior? No. There's no advantage whatsoever. The advantage that is claimed is more flexibility for the compiler vendor. That's never good. Flexibility in a compiler vendor is horrible because it means that from version to version or from compiler to compiler, the programmer doesn't know what's going to happen. That's never good. All right, I'm going to go ahead and wrap it up. A lot of windows open today, huh? Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you. As always, if you would like to follow along with this series at home, you can always go to handmadehero.org and pre-order the game. It comes with the source code, so if you want to follow along at home, you can do so. I will be back here tomorrow for a little bit of fun with the Octahedral number. We'll finally get to sort of play around with it. I think that'll be interesting. And I'm pretty happy with the direction it's going. I think we're getting to the light at the end of the tunnel here. I'm pretty happy about it. So hopefully we'll have some good lighting soon. And maybe we'll see the first little glimmer of that tomorrow. That's it for today. Hope to see you back here tomorrow. Till then, have fun programming, everyone. And I will see you on the internet. Take it easy, everybody.